Hey guys, all right, so 3.1, we're going to start talking about exponential functions. Remember, an exponential function is in the form of f of x equals a to the x, where a has to be greater than 0, but it can't equal 1. It's called an exponential function with a base of a, because a is our base, and their exponent is x, and its domain is from negative infinity to positive infinity. So let's evaluate these functions here on example 1. So we start out, it says let f of x equals 3 raised to the x minus 2, and it wants us to find f of 4. So we're looking for f of 4. So we're just going to plug in 4 for our x. So 3 to the 4 minus 2. 4 minus 2 is 2, and 3 squared is 9. Remember, you can pause this video at any time you need to. Okay, so if I'm going too fast, pause it so you can write it down and comprehend it, back it up, do what you need to. All right, so on B, it says let g of x equal negative 2 times 10 to the x, and it wants us to find g of negative 2. So we have negative 2 times 10 to the negative 2. Yes. All right, so they haven't really talked about the exponent rules. It's coming up here pretty soon, but I've got negative 2 times. Remember, if you have a negative exponent, you're going to send it to the bottom and make a fraction. So that's 1 over 10 squared, which is negative 2 times 1 over 100. So when you multiply fractions, you multiply straight across. So I put the negative 2 over 1. So I got negative 2 over 100, which reduces to negative 1 over 50. On C, it says let h of x equal 1/9 to the x. Find h of negative 3/2. All right, so we got 1/9 raised to the negative 3/2. Well, as long as we're not adding or subtracting, we can take this negative 3/2 and we can give it to the top and the bottom of our fraction. So this is the same thing as saying 1 to the negative 3/2 over 9 to the negative 3/2. Well, 1 to the anything is, well, let me back up a second. So then what we can do is, just like what we did in the previous problem, we got a negative exponent on top, so we're going to send it to the bottom and make a fraction. But what if we have one already on bottom? We're going to send it to the top. Anytime you cross that fraction line, it'll change the sign of the exponent. So when I do that, I get 9 to the negative 3/2, to the positive 3/2 over 1 to the positive 3/2. Well, then you had this rule back in algebra. I'm going to write it kind of up here at the top near where it says evaluating exponential. You had this rule that said if you had a base and it was raised to a fractional exponent, so you had your exponent over a root, you could rewrite that as the root of your base raised to the exponent. And it really doesn't matter if the exponent's inside the radical or on the outside. It has to be one place or the other. So I just kind of write mine there in between. So looking at letter C there, that 9 to the 3/2 is the same thing as saying the square root of 9 raised to the 3. And then we have that over. Well, here on bottom we have 1 to the 3/2. So 1 raised to the anything is just 1. So, and then we can keep going on top. We can say our square root of 9 is 3, and we still have that little 3 there, so I'm going to bring it over. And I don't have to put it over 1 because a fraction over 1 is itself. And so we got 3 cubed, which is 27. And then finally D. And D says let f of x equal 4 to the x. Find f of 3.2. So we're after f of 3.2. So we know that's 4 to the 3.2. There's nothing we can do there to help us solve it, so we can just throw this in our calculator. And if I did that right, I should get 84.449. All right, so that's example 1.